Okay, so it's finished with part 2 video here. So then for this power of 5 one, okay, without having to expand loads and loads and loads of terms, the pattern should follow. So the coefficients of the A's and B's will follow this pattern here in order, where A will decrease in power and B will increase in power as we go through the terms. So maybe see if you can predict it first. Pause the video and see if you get it right. So we'll have one lot of A to the power of 5. So that matches that. That's the highest power of A. And you can see that anyway, if you had 5 brackets with an A in, you would at least do A times A 5 times. That's definitely a term you would get out. Just like here, if you got 2 brackets, you'd definitely do an A times an A. Right, the next thing you'd get is you get 5 lots of A to the power of 4, so that's gone down by 1, B to the power of 1. Okay. You'd get 10 lots of A cubed B squared. You'd also get 10 lots of A squared B cubed. You would get 5 lots of A to the power of 1, B to the power of 4, and finally you get 1 lot of B to the power of 5, equally because you do B 5 times. Okay, so for each expansion, because it's binary expansion, as the power increases, the A and B terms just follow the pattern where A decreases and B increases as you go through, and then the coefficients, the number in front of us, so how many of each of these terms you'd have, are told or given to us by this thing called Pascal's triangle, where you just continue to add the previous sets of numbers from the previous row to make the new one. So for instance, the next one would be 1, 1 out of 5 is 6, 5 out of 10 is 15. Now there is a quicker way to get these numbers using a calculator, which is useful, and we'll look at that in the video for the next time. So that's a good question to ask. Thanks for that, Holly. I hope these were relatively useful and not too complicated there for that last one.